Okay, it's time. Time for day 2 of Advent of Code. If this is the first video you're watching, check out the one from yesterday, which explains a little bit about what these videos are. But in short, we're solving Advent of Code, which is a yearly coding challenge, and we're doing it live. So let's just jump straight into day 2 and see what day 2 is, see if it's easy to solve. Okay, so adventofcode.com. So you can see there that we finished yesterday. I'm only doing one part of these, so you see this one star there. I'm only doing the first part, and I'm not doing both because the videos will be too long otherwise. Okay, day 2. Okay, my eyes hit straight to here. They really appreciate your help, and I'm like, since you're already here, they'd really, yeah. So, okay, I don't care about the stuff above. Let's just read this. You turn to check if the historians are waiting for you, but some unusual data. Okay, the unusual data, your puzzle input consists of many reports. One report per line. Each report is a list of numbers called levels that are separated by spaces, for example. Okay, so we have this grid or line by line set of numbers. This example contains 6 reports containing 5 levels, correct. The engineers are trying to figure out which reports are safe. Okay, so we're trying to figure out a property of each line as to whether it's safe or not. The red nose reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both. Okay, so here are the 2 conditions for each line. The levels are either all increasing or all decreasing. Any 2 adjacent levels differ by at least 1 or at most 3. Okay, so some examples from the first line. We got 7, 6, 4. Okay, that's safe because all the levels are decreasing by 1 or 2. Yeah, 7, 6, 6 minus 2, 4 minus 2, 2 minus 1. And then unsafe here because in this case we're increasing, but there is a gap of 5 between 2 and 7. And so that fails this condition of at least 1 and at most 3. And the same with these ones. Have we got any special cases here? Safe because the levels are all increasing by 1, 2, or 3. So an increase by 2, an increase by 3, an increase by 2, an increase by 2. Okay. An increase by 1, I'm sorry, yeah. Alright, this seems relatively straightforward, I think. So, it seems like the approach would be, again, to take the puzzle import, read each line one by one, break it into the respective numbers, parse them as numbers. I'm thinking that I would probably, yeah, I think what would make sense here is, it seems to me that this all increasing or all decreasing, and at least by 1 or at most by 3. And it's, well, sorry, let me rephrase that. What I mean to say is, it's either increasing or decreasing, so it doesn't matter. And the levels just need to differ by these numbers. So if they're increasing, the difference is plus, and if they're decreasing, the difference is minus. So it seems to me that if we took these lines and then reordered them when we parse them, then we could just consider the increasing or decreasing case and the condition of at least 1 or at most 3. So, okay, let's jump into some code and try and do that. So again, I'm going to use Deno for this project. So Deno in AOC2, that's the pattern I used yesterday. So let's go into there, open this in, no, that's the wrong thing. Yep, open this in Vim. We can get rid of the test file, I'm not going to write tests. In Deno.json, I don't care about this stuff. If you followed yesterday's video, I'm basically doing the same as I did in yesterday's video. I'm going to create a run script here, which is just going to be a little bit of bash, because you can never escape bash. No, it's just because I don't want to have to do this. Deno -- allow -read, because we're going to be reading from the file system, main.ts. So if I just put that inside run, open up a terminal here and make that executable, then we can just, chmod +x run, then we can just run this script and it runs Deno for us. And that's just the default code Deno produced. So let's go into main.ts. Okay, so we want to delete the code that it's given us here, and then we will start by, well, actually, let's leave this blank for a second. What we need to also do in here is, let's do the same as yesterday, import.txt. I need to grab the puzzle import. So let's jump back to here, get your puzzle import. Okay, yes, the cursory scan that I'm sure all of you guys do as well, just to make sure there's nothing really odd, like a completely blank line or something. Yeah, okay, so let's grab the puzzle import, and then stick that into this input file, save this. All right, now what we want to do is just read that data. So we'll do exactly what we did yesterday. I'll say grab the text from deno.read. Well, actually, we're going to do the async version again. So I'll say await deno.read text file, and that's going to be input.txt. What the hell is wrong with me this morning? I just cannot type text. Let's have a look at what's inside there. Text.length, and then over here, I can just now use this little run script. And here we are, okay, 19187 in length, that seems about right. Okay, so step one, we want to break them down by line, and yeah, that's step one. So let's just get a line. So we'll go const lines is text.split on new line. And there we are, then we've got the lines. And just again, I think I didn't pay attention to how many lines there were, but I think, is it 1,000 again? 1001. Okay, this is this issue we had yesterday, lines.length -1, I think, which is, yeah, we have a blank line at the end. Okay, so, why do we get a blank line at the end, actually? Is this because there's no new line at the end of this? No, no, it's 2 blank lines. Okay, that's split. It splits on new lines and gives us an empty one. It's no problem. We can deal with that when we parse it. It's not important to deal with it now. We're going to split these lines into numbers and then parse the numbers, and if there are no numbers in the array, then we'll just skip it. Okay, so we have the lines. Now we want to iterate over these lines, and what we're going to produce in this case, we're going to produce a new set of numbers. So this is a good case for map. So we're going to say what we really want here is an array of, let me think about this, maybe an array of numbers. Seems like, yes, if we had an array that contains each line and each element in that array was another map over the individual elements parsed to numbers, then we would have, yes, I think that seems to me to be the right way to go. So let's just try that. So const, what are we going to call this? We're going to call this the, well, it's the reports. Each line is a report. So if we do reports, then we're going to do lines.map. And in each case, we're going to take one of these lines. Let me fill this out. And then in the case of the line, we've got a string. So going back to this data, I'm sorry, I'm imagining in my head. Well, we can see a case of it here anyway. So each of these lines is going to look like this, separated by space. So what we want to do here is, let's get the individual, I'll just call it LMs for now. There's nothing like, obviously, naming things. What's the famous quote? Yeah, there are only 2 hard problems in computer science: cache invalidation, naming things, and off by 1 errors. So yes, naming things not easy, especially live on a video, but it doesn't matter. This is the purpose of advent of code is just to write code that gets you the answer. So that's what's so fun about it. So let's take the line here, and then we're going to split on space, and then that's going to break those lines up into individual elements. Okay, cool. So what we've got there is LMs, but what we actually want to return is not that array, because if we return that array, not only will it contain, well, they won't contain the spaces. For example, if we just log these out as we do them, then it should confirm, yeah, it's just saying that it's not used. It should confirm what we think, which is that it's now given us the individual numbers, but of course they're all strings, so we don't want them as strings. We want them as numerical values because we need to do a comparison on them at some point. So what we should do here is we essentially want to take each one of these elements that we're outputting here and remap it. So that's the map inside the map that I was imagining in my brain before we started doing this, is that what we'd really ideally like to do here is return the lms.map, and in each case one of these elements is a string version of a number. So probably don't need to do anything special here. Well, actually the one case I do want to, no, maybe it's not important right now. I'm thinking about that empty case at the very end, but we'll deal with that in a second. Excuse me. So I think we can just do something as simple here as saying take the LM and then parse in on that LM, and then bear in mind these are the string representations of the numbers, and then what we should have in reports is now the numerical versions of all of those things. Yes. And we have, yeah, let's just see what that last one is, because we've parsed in on an empty string, which I think is going to produce nan. So if we do reports.length -1 here, yes, we have an empty one with nan at the end. So what we actually need to do after the map here, ideally, is we want to filter the elements inside this array to make sure that we don't have one with nan. Or what we could do potentially is, we're actually parsing a nan into this and then mapping it. Maybe it would make sense to just return. Would it make sense to return null? If we returned null or undefined there, we just have another value in here, so it's not especially important. I don't think there's a case here actually. Maybe the condition could be as simple as that the array length is actually 1. Let me think about this for a second. What's the easiest way to solve this problem? Maybe just get rid of the last line. That seems like the easiest way to solve this problem, right? So if we can say slice here and just get the last. So signature on, I always forget the signature on slice is start, which is a number, and end, and then the inclusive. Start at the beginning index of the specified portion of the array, and then the end is a portion of the array exclusive. This is exclusive. The element at the index end is exclusive of that one. Okay, can you pass? Can we pass -1 to these things? Let's just quickly jump in the console here and test it in this way. So if I have 2 elements and then I say slice -1, do I just get the? Okay, I see. We don't want that because we want to get rid of the last one. So we want to get rid of the last one. What we want to say is that we starting at 0 gives us the whole thing. Starting at 0, can you do -1 there? Ah, that's quite handy. Does that work as we expect it to? I think so. So -1 with an array with more elements. Okay, that's a nice API. So let's do that. Let's just do slice 0 -1. So start at index 0 and then take off the last one. And then here we can get rid of that. The last array now is a real one with numbers, not that last weird end of line split thing going on. So that just simplifies parsing here. Okay, so there's no need to do a filter now. And switching back to the output, what we've actually got is an array of arrays that contain numbers. Now, going back to the beginning, when I introduced this problem, I think that it would be easier if we ordered. Some of these are increasing, some of them are decreasing, some of them won't meet the criteria, but if I take some examples here, 57, 61, 62, 65, this one's an increasing one. Do we see a decreasing one somewhere? Probably somewhere. But we know we have decreasing ones for sure, because it was mentioned as a condition, but I don't know, I might just be unlucky and not finding one right now. I'm expecting to find one that decreases somewhere though, because it does mention it in the challenge, right? Scroll a bit further. Maybe it's broken down into 2 halves or something. I'm not seeing any decreasing here. But there must be one. There'll be one somewhere in the data set. But the important point is that some of these are going to increase, but we're going to have some cases as well where it decreases. So it's really bugging me that I can't find one that's actually decreasing here. But there has to be one because it was mentioned. So oh, there we go. There's one that, well, that decreases and then increases. I see. Okay, so 46, 45, 47, 49, 51. That's interesting. So this is a case here that I didn't expect to find. I thought they would always either increase or decrease. It says here that figuring out whether the report is safe, gradually increasing or decreasing. So a report only counts safe if both of the following are true. The levels are either all increasing or all decreasing. Okay. So my assumption that we would be able to just reorder these numbers is not quite true, because if we did that, no, that wouldn't work anyway, because it won't work now, because here we can see a case where of this happening 46, 45, 47. So if we actually reordered that, we would lose this, which is an invalid report, because it has to either increase or decrease. And in this case, it doesn't do that. It does both. It decreases and then it increases. So this would be considered out. Okay. Let's see. So I'm going to have to rethink the solution here. For now we've got the reports. Let's create a function here that can tell us whether a report is safe or not. So if we call that safe, and then it's going to take a report, which in this case is a number array, and it's going to return true or false. We'll let that be inferred. I feel like I need to explore this a little bit more in my own mind now. So the report is going to be an array. It's going to have numbers inside it. That's what we're going to pass to this function. And then it's going to say yes or no based on whether the numbers go consistently up or down. Could we take these problems, maybe we could take these problems one at a time and say, we could pre-process the list and remove all of the ones that are not safe based on the first condition that they're either increasing or decreasing. The ones that do both are just invalid. We don't even need to get to the second stage. If it passed that check and we knew that it was only increasing or only decreasing, then we could sort them, and then the final step would then just be to see what the deltas were between each of the numbers. So that would be, I feel like that might be a bit overkill, but that's one way we could do this. And that way we wouldn't need to have a function that contains too much complexity of saying, first of all, does it increase, checking that it doesn't also decrease, and so on. So maybe we could do that first. So let me say that, let's get the result of this function here, safe, and let's pass it an example. This is essentially a test now, but not written as a test. So this one is, this function is not called safe anymore. I'll rename this in a second, but this should say false to us because it goes up, 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 and then down. So let's rename this. It's not going to be safe. It's going to be something like one direction. I'm not quite happy with that name for obvious reasons. But we're asking the question, does this report go in only one direction? If it goes in both, then no, and we can filter it based on that condition. So we're sort of writing a thing that we'll be able to put into a filter here, to reduce that report down to just the ones that contain numbers that go in one direction only, not in both. So let me see what's the best way to do this. I feel like we need to go through. Let's start writing some code. So if we let I equals 0, I less than report.length, and then I plus plus here. So we're going to do a very traditional for loop because I feel like I've not got it clear in my head just yet exactly how we've solved this problem, but if we're going to go through the report to figure out whether it goes only up or only down, well, let's break this down into smaller steps. So actually let's just say that it's increasing, then we can do an inverse version of that, decreasing, and then one direction can be increasing or decreasing. So that way we break the problem down into smaller, easier parts to think about in the brain. So in this case, we're going to say that this is only increasing if report 0, not O, if report 0 is less than or equal, I think increasing can still, yeah, okay, so I think it needs to be equal, less than or equal to report 1. Now since we're doing a plus 1 here, we'll need length minus 1 in here, right, because otherwise it's going to overrun the array. So if we do this, if report, and it's not report 0, it's going to be report I, and then respectively I plus 1 is going to check the next one in here. If it's less than or equal, then it's fine. So it's actually what we're trying to do is check the opposite case, so we can break out a loop and return false. So we're going to say if report I is greater than report I plus 1, that would mean that the first element, for example, was 0, the second one was 1. That is, sorry, the other way around. It would be, the first one could be the number 1, the second one could be the number 0, and that would be is not greater than. So here we can say return false, and then at the bottom of the function we return true, because if it manages to pass that for every single one, then it looks like we have an increasing. So let's just change this for a second to say increasing, and if we do a positive test here, that should be true. Yes, because it's 1, 2, 3, 4. However, 1, 2, 3, 3 will say true as well. That's not technically a definition for increasing, but it meets the definition that we need for this challenge. Or rather, it doesn't matter because when we reorder them, they'll still be next to each other. However, if we do 2 there, that should say false. Good, okay. So we have increasing. And then, okay, so at the cost of John Carmack's code duplication, let's keep this code really simple to reason about, and we'll say decreasing. Now, that's basically the same. However, if it's decreasing, that means that the first element needs to be less than or equal. No? Let me think about this for a second. If it's decreasing, then let's say the first element was 1, then that one would have to be 0. Yeah, I don't think we need the equals. I need to think of a case here. Let me just stick a... Let's assume if we're testing if this is decreasing, then it would be decreasing if it was 10 and then 20. So we're saying if the first element my brain's bending here, because if the condition is greater than, it's the same as the function above, which is obviously not. Actually, if we know now, increasing is not the opposite of decreasing, so we can't just say not increasing, because there's a case here where we get true or false. So the map is of possible values is true, 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 false, false, false as well. So it's the false, false case where it's neither consistently increasing or decreasing that we need to take account of. Okay, so in this case, to determine that it's... So increasing is as we just showed there, that is increasing. Decreasing would be, to use that example, that it would be like 3, 2, and 1, and so on. So here it would be that the first element, that if I is 0, it needs to be greater than the next element. And that would be that it's decreasing. That's right, so we need the opposite condition. So because we're actually returning false here, we're trying to get... So if it's less than, then we return false, because if it's less than, it would be, for example, that this one is less than this one. Yes, okay. Sorry, folks, my brain froze a little bit there. Okay, that makes sense to me now. And based on that, then we could do decreasing with the same, that should say false. Well, increasing is saying false now as well, because it's not actually a case where it increases because of that. Okay, so now that's true. And then here, that will still be false because it's actually increasing. But if we did it the other way around, 3, 2, and then 1, get rid of this 1, that should now be happy with the fact that it's decreasing, true and true. Okay, and then we can produce the function that we wanted to produce, which is the unfortunately named one direction. And that's also going to be a report that's a number array. And here that's just going to be that it's either increasing report or decreasing report. If it's not increasing, then test if it's decreasing. It could be neither. So I feel like what have we got here? We can now say one direction there and then one direction for here. No, I just don't like this syntax. Let's just actually do it properly. And then that needs to be a return statement. Okay. Oh. If only I could type. So when I run that now, it's saying true. They're both one direction, and that's correct because we've got 3, 2, 1 and negatively, yeah. So if we break this though, and we make it do something else, if we put a 5 there, that's the first one's no longer one direction. Good, we get a false. And then if we do the same thing here, if we introduce 4, that will still say true. Yes, good. And if we introduce like a 3 at the front, that's not going to be true. Okay, good. So some utility functions to test whether an array is going up, an array is going down, and then really what we want to really check is whether it's going in one direction. Of course, this could all be condensed into one function that just does both things, but it's fun to work through these steps one by one and put them together, and this code is at least a little bit more readable, if not a lot longer though, as a result. So let's take this function, because these sort of, actually let's put that back. What I want to do in fact is take that stuff and then put it down here, because I'm not going to pull these into a different file right now, that seems a bit overkill. But these are sort of utility functions here, and then we're doing the actual work down here. So we've got the reports now. Inside the reports we've got an array of other arrays that contain numbers, and what we should do now is so I expect I saw one there in the test case I saw one in the data when I just looked at it that was broken. It wasn't going up or down. So let's what I want to do here is say reports.length here as the first output, and then let's use this one direction now to actually filter that. So I'd like to put the filter on there, but I'll do that in a second, because I want to output the before length and the after length to make sure that we're actually getting rid of some of them. And I imagine, yeah, there'll still be quite a lot left if this is correct. So we want to say here, let's just say OD reports. It doesn't matter, because I'm going to delete this in a second anyway. And then we're going to say reports.filter. In the case of each report, we're going to filter it on the condition that it's in one direction. So now we can use that function that we wrote up there to say filter it based on the fact that it's in one direction. And then let's do this again, and that's going to be OD reports. Great naming going on in here, by the way. Okay, yeah, that looks pretty good. So we have 1,000 to begin with, and out of that 1,000, it seems like once we get rid of the ones that break the chain in terms of consistently going up or down, we end up with 772. Okay, that sounds about right to me. So what I'm going to do now is just take the filter bit off that, and we'll stick it on the end of there, so that, oops, stick it on the end here. More of a map filter going on, and then just to check, that should still be 772. It is. Okay, so we get the reports, we get the lines, we map over those lines, and split the elements down into parsed numbers. Then we filter those arrays based on the ones that, well, we include only the ones that are going in one direction. Okay, now what we could do at this stage is now all we know now is that they're going in one direction, but we don't know if they're going up or they're going down, and it would be a lot easier if they were all going the same way, because all we care about at this stage is we've met the first condition that they're either increasing or decreasing. We need to check whether the distances are correct, and for that we can go through each element and just make sure the distances are not bigger than a certain amount. But before we do that, it would be annoying if we had to consider that the differences could be backwards or forwards, positive or negative. So if we just sort the numbers, that would be one way to do this. We're only talking about 1,000 elements, so if you're watching this thinking that'd be really efficient to do all this work, yeah, it is efficient, but it's on a data set that's 1,000 elements, so efficiency doesn't come into it anyway. If you do want to make a more efficient version of this, there's probably something much more clever we can do here, but I'm not optimizing for that. I'm just optimizing for the steps being very understandable and as small as possible. So it seems to me like the best thing we could do here is map once more. Don't you just love filter and map? We now have an array of 772 elements, and inside those, some of them go up, some of them go down. So let's make sure that they all go the same way. So we're going to map each report in there, and we're going to... The annoying thing about the sort function is that it will sort in place, so it actually modifies the original array. So for this to work, I think what we're going to want to do is say report or sort, that will sort in ascending order, and then we need to return that same report that was modified back as the map value. Yes, and because sort does not return... Oh, it does. Maybe this has changed since last time I knew about it. Sorts an array in place. This method mutates the array and returns a reference to the same array. Okay, so it doesn't mutate it in place, but because it returns a reference, at least we can now do that. Okay, good. Which means I can also now actually just, yes, make it slightly more clean by taking this away. Oh, I was trying to, you do that thing where you take away just enough grammar so that Prettier figures it out like that. Okay. Now we still got 772 there, but if we print these out, we should see that they all increase now. I mean, it was hard to find a decreasing example before, but they all increase now, surely. I mean, it would be pretty easy for us to check that because we could just run through them and actually call our increasing function now. In fact, let's do that. Let's say there is it's sum, or is it all? I thought there was an all function on arrays. Is it called something else? Fill, find, flat, keys, push, sum with, oh, it's every, not all. So every runs through every element in the array and runs a condition on it. So we can say that it's increasing E. So, oh, okay. That says false. That's curious, because they should be all increasing since we just sorted them. Did I get something wrong here about every? Determines whether all the members in an array satisfy the specified test. Yes, that's what I wanted to do. That's made me very curious now. If that returns false. Okay, yeah, I'm a little bit surprised by that. So let's what do we do here? Let's do reports.forEach, and then I can then print out the one that doesn't. So if not increasing report, then let's just print out which one it is that wasn't increasing, because something's not meeting my expectations here. Oh. Yes. Okay, I see what we've done. I see, this is, yes, a silly mistake. The idea that the implementation of increasing and decreasing is not correct, because it only checks whether adjacent cells are increasing or decreasing. It doesn't check that there isn't one that decreases from the previous one. So if we look at the output here, for example, I can see straight away that, okay, 10, 12, yes, that increases, this increases, this increases, this increases, and then that. No, wait a minute. These should not. Let me think about this. So we filter based on the fact that they're one direction, and then we do this map. Let's just remove this temporarily. So we just do the filter. We had 772 at that point, and then this is a bit confusing. If not, I think I know what is happening here. Yeah, I think I know what's happening. So if it's not decreasing, sorry, I need this as an and. If it's not decreasing and it's not increasing, yes, we get none. That's at this stage. Then with the sort though, the sort then, apologies, that's not correct because I haven't semi there. Suddenly, okay. This is because I think array sort JS. I think it sorts based on text, right? It's not sorting based on numbers. Okay, there we go. The default sort order is ascending, built upon converting elements into strings. Thanks, JavaScript. Really helpful. Okay, so we don't want to sort we don't want to just call sort like this. We need to sort based on the numbers themselves. And you can pass a sort function into here, I believe. So let me leave this little this down here, because this is going to tell us if any of these is broken. So I'm going to change this now, this sort function, to be, let's not do this inline, let's do it as a function. So we're going to say return report.sort here, put that bracket in there, okay, because what we're going to want to do here is pass a function. So if we just take the type signature from this, you can pass a compare function which takes the two elements. Because we're in TypeScript, it's actually, this sort is actually typed based on the number. It's just that because we don't pass a compare function, it does the default behavior, which is convert the underlying values to strings. So there you go, there's a nice little helpful thing that's come out of this. Don't just call sort on numbers, it's strings. I think I knew that and forgot at some point. You just expect that a sort function works on the correct type, especially when you're working in TypeScript. However, if I pass the sorting function, the comparison function, then it will do the correct thing. So if I do like let's do the classical I and j, and then we want to say that I is less than j here, I believe. Now I don't need to type, or do I need to type those? Oh, that's right, you don't return boolean in sort, you return the difference, so I minus j is what we actually want to return. But those are types, yeah, that's all. The inference there is working quite well. So let's run that again. Okay, now we're getting what we expected to get. That sorted them as numbers now, not as strings, which is much more helpful. And actually, let's just make sure I got that direction right, because I can never remember precisely. Yes, those are still increasing. Okay, it's important that we know that we're sorting them in one way or the other, because then when we write the code that checks the distances, we know we're checking for distances that are bigger, not distances that are less. We could do it either way, but yes, I minus j is doing the right thing there. Okay. Yes, and in fact, if I go back to the version of the code that I wrote originally here, which was testing every, that should work fine now, as we just saw in the code a second ago, but let me just do it this way anyway. So every is going to take every report, and it's just going to make sure that the report is increasing, and then that should return true. So if we just output what the value in E is, we should be seeing, okay, perfect. So of the 772, I believe, we can say reports.length here. So of the 772, every single one of them are now increasing. So we've reduced the problem down to, we've taken away a lot of the stuff of they're either all increasing or all decreasing, and some that the weird mix is where actually some of them jump up and down. This is a lot of work. I hope this is not wrong, because if this is wrong, there's a lot of work to go back on here. Anyway, let's get rid of these two lines. We're back at the position where we thought we were a second ago, where we've taken, let's recap the whole thing. So we've taken this whole text, we've broken them down into the individual lines, we've broken the lines down into the individual elements and passed them as numbers. And we've got an array of those, so we have an array of arrays containing numbers. Then what we've done is filter that overall array of arrays down to contain only the ones that either increase or decrease. Yes. Dropping the ones that don't have any, that don't continually increase or continually decrease. I should say continually decrease, really. That's what we're testing for here, is that each number is bigger than the last or greater than the last, and so therefore it continues to go up and doesn't go down. So then what we've done after the filter stage, which is here on line 33, we've filtered them to make sure that they go in one direction, and then we've picked a direction by saying that we're going to take every single one of them and remap them again, and we're going to sort them into ascending order, numerically this time, not as strings. So now what we've got is a much more usable data structure that we can work with, and it feels like what we need to do now is simply count up the number of them that do increase according to the other criteria. That needs to be, what did it say, 1 to 3, I believe it said, right? Yes, at least one. So, okay, so they can't be two this one, for example, 4, 4, yeah, I wouldn't say, oh, there we go, it actually says it there. Because 4, 4 is neither an increase nor a decrease, because that's not at least one, that's exactly 0 difference between the two of them. Okay, So, and at most 3. So we just need to go through each of them now and then make this check for each respective case, which is kind of what we did with the for loop above, and I think that's probably the cleanest way to do it again. So let's do it that way to begin with, and we're just going to do some really basic here and say we'll keep sum as 0, let of course because we're going to modify that, and then we're going to have to iterate over all of the reports. So I'll do that at least in the for each. So we'll do reports.for each, so we can go through each element inside there, take each report, and then what we're trying to do is count how many of those meet this criteria. Of course, what we could do is write another function here that's similar to one direction and decreasing and increasing, that says, like, in this case, increasing by at least 1 and at most 3, and then we can use that for a filter. So we can refactor that afterwards, but let's do it this trivial way. I can leave that as an exercise for you. Let's just see if we can get the right answer, because we've spent quite a long time on this already. So reports.for each report, and then what we want to do here is like go through each element in this array. Now it's increasing, so we're going to start at 0, which is why I sorted it that way to begin with. I equal, it's impossible to type and code at the same time, I feel like. And again, that's going to be like we did above, reports.length, which is the less than reports.length is the last index, but we want the last index minus 1, because we're always going to be checking the index plus the next one, and then we're going to increase that. Okay, and now the condition for us to skip this iteration and not add to the sum, and not add 1 to the sum, because this is a binary thing, right? This is either the report is safe or it's not safe, and it's safe if all of the increases meet that criteria. So it might be, what's easier to look for? It doesn't matter. I guess we let's do the positive case so that the code is a little bit slightly more readable, I guess. We're going to say if reports 0 is, so the first, let's do the first part first, that's is at least 1. So at least 1 is greater than, right? So because greater than equal could include the same 1. So we say is greater than reports, I've done 0 again there, this should be I plus 1, because my brain thinks about the first iteration all the time. If reports I is greater than reports I plus 1, then we know that it's at least 1, but it also, reports I also needs to be less than, this is at most 3, so less than or equal to, no, what's the, this seems, we're missing a step here, right? We need to know what the delta is. So let's just grab that for a second. The delta, the difference, let's call it diff. The diff between the two numbers is report, and since they're always increasing, it's going to be reports I plus 1 minus reports I. Now that's the actual difference. That's what we care about. So actually, a good way to, one way to do this would have been, we could have also used maths ab like we did, math.abs, sorry, for the absolute difference like we did before, had we not already got to the stage where we already know that they're going in one direction. So no need to do it in our case, but if you'd gone about this a slightly different way, you could have, I suppose you will be doing that at this point. Anyway, we've got the diff here, so we take the, in theory, bigger number, and we subtract from it the, in theory, smaller number. It could, of course, be the same. And now the condition that we are checking for, let's get rid of this line again, so because we're going to rewrite this. The condition that we're checking for is that diff needs to be greater, greater than 0, because it needs to be 1, and it needs to be less than or equal to 3. Is that right? It says at most 3 and at least 1, so 1, 2, or 3. So that's greater than 1. Greater than 0 is 1, and less than or equal to 3 is 1, 2, and 3. So if it's that, then we're going to say sum plus equal 1. And then, what have we got wrong here? I'm a little bit confused about why that error has come about. That's the number array. We're going, surely this is as well. Oh, yes, you probably noticed that while I was doing this, and you were screaming at the YouTube video saying, you've typed the wrong one. Yes, sorry, I need to do the individual one. Okay, and then if diff is greater than, so what's wrong with this? Expression expected. Diff. Wow, it's obviously a slow morning. Okay, and then let's see the console.log, the sum. This is a sum of reports that are safe. 3680. Okay, let's just see if that's actually the right 3680. Let's see if that's actually the correct answer, because if not, it's not the right answer. You're too high. Okay, so we've got something wrong here. It's much more fun when something goes wrong anyway. What was the total number of 672? Yeah, that's obviously wrong because it's bigger than this number, 772. What? Okay, I'm doing something very stupid there, right? I know what I'm doing. It is a slow morning, isn't it? What we're trying to, we're not doing sum plus equals 1 there. Of course, that's very stupid. We're going through every single one of the elements in the array, and the case is that this needs to be true for all of them. It's only when it's true for one of them, when it's not true for one of them, that we're not going to add to the sum. Not add to the sum when it's true for the individual bits. Of course, that was a bit silly to do it that way. So what we really want to do here is say that if the diff, let's do the we want to do the negative. Yeah, so we're gonna, let's spin this around and say that sum is plus equal to 1 if it's correct after the for loop is finished, and then the responsibility of this for loop is in each individual case of to find a diff that's actually invalid, and if it's invalid then it won't count, and it will skip over that specific report because it's invalid, so it won't count. So we can actually hit a return here and just jump out of the function altogether. But of course this condition is not right anymore. So we're saying the invalid condition is if the diff is, it won't be less than, but we can say less than or equal to 0, or the diff is greater than 3. So less than or equal to 0, so we got 1, 2, 3, and then 4 is outside of that. So let's see that. What does that give us now? 534. 534. Is that the correct answer? That is the right answer. Okay. That took way too long to get to. I mean, in some ways, when you do all these for loops and iterations, you're thinking about a lot of detail, and another element is also when you're narrating what you're doing, it makes it a little harder to also think deeply, but got there in the end. So I feel like this is, it's not a bad solution. It's a little bit of a verbose solution, and there'll be there'll be other ways to just reconsider this problem altogether. I've done this in the simplest way, truly the simplest way, by just taking one step at a time and basically following the same logic that it essentially lays out for you here by saying, here's the things, in each case, look at this, look at this, look at this, ask this question, ask this question. That's what the code is literally doing. So let's briefly recap, as this one's taking a bit longer. Let's briefly recap about what we actually did here, because the crux of it isn't in all of this, but it's enabled by these functions we wrote above. So, first of all, not first of all, but eventually we came to these three utility functions of, tell me whether an array of numbers is increasing, consistently increasing, or tell me whether it's consistently decreasing, which are just inversions of each other, of course. And it's possible that they're doing neither of those things, that they're not increasing consistently or decreasing consistently, because they could be doing that inconsistently. So, but the reason we wrote both of those is so we could implement this function one direction, which tells us whether something is doing one or the other, because in the data set, it can be increasing or decreasing consistently, like the cases there where that's decreasing consistently and that's increasing consistently. So the one direction tells us whether that's true. Then we jump into the actual work here on line 25, and we say read the input, and then break the input down into lines, and then drop the very last one, because the very last one is not a line we want to deal with, so it makes the code down here a bit cleaner. We should have done that in yesterday's example as well. So then we say, okay, given the lines, which are now just textual lines, each line is going to consist of these individual numbers separated by spaces. So we're going to map over the lines and produce a new array, and the new array initially is going to contain each line broken down to spaces and then internally mapped into numbers. So we go from the textual representation to the numeric one. Then, knowing that of those numbers, some of them may be not going in just one direction, they might be going in more than one direction, and we want to cancel those ones as well as we do the band. And then, so we filter the list down. So it goes from about 1,000 elements here, well, what exactly 1,000 elements here, down to like 772, I think it was, after this filter, because we take away the ones that are not consistently moving in one direction. Then, once we've got those, we want to then just sort them all the same way, because now that we know that they're consistent, we can sort them. So we just sort them in an increasing ascending order here, and then at least we're dealing with a much simpler input. If the challenge itself was written that way, this would be really easy to solve because all that work would have been done, and we would know that we just had an array of numbers that were all going up, and also really asking is what are the differences between the numbers? Are they in the range 1 to 3? So that's basically what this last bit of the code does, is just determine that, and it does it in a fairly imperative way again. We take the sum here. There's plenty of ways we could do this with reduce, but let's not make the code any more complex. So we create a sum, start at 0, we go through each report, and then in the case of each report, we iterate through each of the numbers in the report, comparing first of all, we calculate the difference between the, in theory, higher number and the lower number, and then now, after a little bit of back and forth here, we say that if the difference is less than or equal to 0, which it can't be, these are definitely increasing numbers, or the difference is greater than 3, then just skip this entire iteration for each, because it's not a valid report. However, if it manages to go through every single one of the numbers in the individual report and doesn't hit this condition, then it's clearly a correct report, a safe report. So we add one to sum, and then we just log sum out. And again, that gives us this number 534, which is correct. Certainly not that, which is bigger than the array itself. Okay, a bit of a longer one today, taking a very step-by-step approach. But yeah, hopefully that was interesting, and I imagine you guys have come up with even more interesting solutions to this with a bit more time to sit and think through it, and maybe there's probably something in there that's much more interesting when you figure it out and enables you to solve this in a slightly more interesting way. So let me know in the comments of this video if you've solved it in a more succinct way, which I'm sure most people have. But hopefully this was also interesting just to work through it step by step and see how we can solve the problem in the tiniest steps one by one, and then pull them all together in the end. Right, okay, that's today's Advent of Code, so we'll be back for tomorrow's. I'll see you then.